Geotechnical Engineering Part A, Soil Mechanics, Chapter 12, Shear Strength of Soil. So we want to study the equation of shear strength, which is tau is equal to C plus sigma times tangent of phi. So if you apply a horizontal force to a soil layer, you can easily see the first part of a resistance of that soil is due to cohesiveness of the soil. So this C stands for cohesion term of the soil, and then that is applied to area of B times L of our element that consists the frictional the resistant force, which is equal to the applied force, and oppose that one. And the other component is the frictional term. The heavier the soil mass or friction, and it just says friction force is equal to times Fn normal force. And if you go beneath the soil layer, you can easily see the frictional force, which is resisting the applied force, horizontal force to the soil. If you go to equation of tau is equal to C plus sigma times tangent of phi, can easily see the cohesion term plus frictional term. Again, the cohesion term is to cohesiveness of the soil grain materials, and also to resist the applied force, horizontal force, and also the frictional force, which again, the first component, C, stands for the cohesion term, and also sigma times tangent of phi is a frictional term, which we observe them in closer looking details. So again, let's focus on the cohesion term. So if a horizontal force like Fa applied to a soil sample, soil element, so you can see these small arrows, which is cohesion of soil. Then you apply that cohesion to area times B times L. It just of the resistance force, and force over the area is a kind of stress, and our stress is like a shearing stress, which is again this tau is equal to the cohesiveness of soil. So one can say the first component of tau stands of t tau1 plus tau2, and the first component of tau is the cohesion of the soil grain. And the second component of tau, if you the soil element again, as soon as you apply a horizontal force, the heavier the load, the more friction, and the frictional force is the opposing force which prevent the soil sample from, and, and if you divide the frictional force over the area of BL, it should be this cancel out the same applied force over the same area, and FF is frictional force. If you replace it from here, is nothing but mu times normal force. Then as soon as you can see here, Fn over BL is a sigma, and mu times that sigma, it just turns it to a horizontal force, which is our tau2, which is the second component. We already observed the first component of tau, and now if you observe the second component of tau happens at the soil beneath, and that should be cancel out. The Fa over Bl is also the applied shearing stress. So at place shearing stress should cancel out the shearing stress which is applied to the soil, prevent the so tau 2 is equal to mu times sigma, which is, we call it the second equation, the second component of shear strength of the soil. So if you develop the triangle of friction force, normal force, and the resultant one, the theta created between the resultant and normal force, we call that angle of friction. And if you get the tangent of theta, that's simply tangent of this angle is simply a FF frictional force over normal force, and that's nothing but angle of friction. So if tangent of theta is FF over Fn, we can rearrange the equation based off frictional force, and one can say frictional force is normal force times tangent of theta. From the other equation, normal friction force, normal equation, the main equation for friction force is just friction force is mu times normal force, and if you equalize these two terms, it just says mu is nothing but tangent of theta. Coefficient of our friction is nothing but tangent of theta. If that's the case, and if we add up the two component of our tau to get the main equation, it just says is equal to C, tau is equal to C plus mu times sigma. And if mu is already tangent of theta, one can say tau is equal to C plus sigma times tangent of theta. We almost created our main equation. The only difference is we have theta here, but we have tangent of phi original equation. Let's see how that goes. So when we have a shear stress of soil layer over the soil layer, can easily interpret theta, convert theta to phi, which is that we can easily say now angle of friction when we have the shear stress of soil layer over soil, that change to angle of friction of the soil. So that's why we can replace theta by phi, because we have the shear of soil over soil, and in that terms tau is equal to C plus sigma times tangent of phi. Can get our shear. That's a conceptual and also mass understanding of the two components of shear stress. Thank you. Solve more example